In today's video, I will be discussing Physics 251 Video Explainer Problem 55. In this problem, we were given the acceleration and the initial time for a rocket to accelerate up, and we are tasked with finding the rocket's maximum altitude and the duration of the rocket's flight. So what I've done is I've written a few of the kind of things that we can get out of this initial problem here. So here we have the acceleration, also seen here in meters per second squared. We have the time in seconds. And since we're working in the Earth system, we know that acceleration due to gravity is negative 9.8 meters per second squared. So what we're going to do initially is we're going to set up a relationship between the initial velocity and the acceleration and time in order to get the final velocity for the first half of the flight before the rocket runs out of all of its fuel. Or I guess when the rocket runs out of all of its fuel. So here you can see this equation here. We are plugging in 0 and acceleration times time again here and getting out this number here for the final velocity as the rocket runs out of fuel. From this point, we're going to be calculating the height that this occurs by kind of using this scheme right here. We can imagine that there is a triangle right here, and we are calculating the height of the triangle. Well, we know the height of the triangle, and we know the distance right here. So this right here will give us the, this equation for the triangle will give us the height in meters. From here, we're going to start thinking about the Earth system. So we're going to plug in the constant that I mentioned up here. This is the acceleration due to gravity. So we're plugging this in because the rocket is now in free fall. As you can see, the velocity is starting to point in the negative direction, which is going to give us a negative velocity. So here we have our equation relating the final velocity of the second half of the trip right here. This is what this distance is. And so we're going to try to find what the peak is here. So we're plugging this in, and we are going to solve for y. And this y will give us the total height traveled, where you see we're using our height in meters that we got from the last problem. Yeah, so next we're going to be relating the height, the initial height, the initial velocity, and acceleration times time squared here. And once you plug in all these variables and solve for 0, you actually get a very familiar looking equation, which is a parabola. So if we plug this parabola into the quadratic formula here, we get two different values. So you can see one is positive and the other is negative. Since we can't have negative time, this is not an option for us. And although we aren't finished when we choose this option here, because we still have to add the initial time that we were given in the problem here, this t equals 30 seconds. We have to add this to the 197.55, leaving us with a final time of 227.55 seconds for the rocket's flight duration. I hope this video has been helpful, and thank you for watching.